So hello friends, today we will see the 4:1 multiplexer using verilog. So let's see our content table first. Here is our content table. So first we will see the introduction to our multiplexer. In this video, in introduction, we see the what are the multiplexers, how they work, then function table of the 4:1 multiplexer, in which we will see the diagram of multiplexer and its function table, its circuit diagram, then we will see its code and its output and simulation. So first we will go to the introduction to the 4:1 multiplexer or general multiplexers. So basically multiplexers are the device which have multiple inputs and single output, and they are also called as data selectors, and which are enables the single output to be shared by the multiple inputs on the basis of select lines. So let's go to our function table part. So this is our function table. So it is the diagram of function table. On left side there are inputs, on right side there are single output, and on the base there are two select lines. On the basis of select lines, we drawn our function table. So we can see here. Then next we will go to our circuit diagram of 4:1 multiplexer. So basically here D0, D1, D2, D3 are our inputs, and A and B are control signal, which are nothing but act as select lines. And here we get the 4 AND gates for D0, D1, D2, D3, and after applying the OR gate, and we get the single output for 4:1 multiplexer, which is the circuit diagram of 4:1 multiplexer. So let's see the code part here. First we will declare the libraries, then our entity part, then we write the architecture part. So here first we write the entity library part. So here we are written the libraries all. So then our main code is start with the entities. So here we are given name of entity mux underscore one. After that port section. In port section we are denoted our variables, input variables and output variables. There are two input variables and single output variables, which is y. So d and s are input vector form variables. So d is input in vector form 3 down to 0, and s is input in vector form 1 down to 0. Here we end our entity and start with architecture. So let's see the architecture part. So architecture behavioral of mux 1. In this line, behavioral is the name of architecture and mux underscore 1 is the name of entity. So this is the architecture part. So there are three types of modeling. Among them, we are using the behavioral type of modeling. So this code is written in behavioral type of modeling, in which there are processes are written. So in processes we are written our two input variables and their cases. So this is our architecture code. Then we end our first case, then its process, and after this we end our architecture. So basically it is the program for the 4:1 multiplexer. So let's see the test bench code for the 4:1 multiplexer. So here we are written all the possible conditions which are written in Verilog code. That's all condition we are written in test bench code also. So these are the all conditions we can read here. So last we end our processes and end our code. That's all about the code. So let's see the its output. So this is the output of the 4:1 multiplexer which gives 1. So thank you.